we've been given a line L with the equation 3y minus 4x plus 21, and the point P, which has coordinates 15, 2. Now, we're supposed to find the equation of the line perpendicular to L, which passes through P. So now, just from the line, we know that the gradient of L would be equal to -1 upon the gradient of the line. Okay, so if you just go ahead and rearrange this equation that we have for L to find the gradient, we get y is equal to 4 by 3x plus 7. So now we know that the gradient of L is 4 by 3, and since the gradient of the line is just its negative reciprocal, we know that the gradient of the line is just going to be equal to -3 by 4. So from this, we know that the equation of the line is just going to be y equals -3 by 4x plus a constant c. Now, to find the value of c, we can use the coordinates of p as the line passes through p. And so if we just substitute the coordinates of p into this, we would get 2 is equal to -3 by 4 times 15 plus c. And so c, if you put this into calculator, would be equal to 53 by 4. So then our final equation for the line would be equal to y is equal to -3 by 4x plus 53 by 4. And to make this a bit easier on the eyes, we can multiply the whole thing by 4, and we should get 4y is equal to -3x plus 53, and 4y plus 3x is equal to 53, hence solving this part. So for part B, we've been asked to hence find the shortest distance from P to L. Now we know the coordinates of P. We know that P is equal to 15, 2. And now we have to just find the shortest distance from this coordinate to our curve L. Now to do that, we know that we would have to find the intersection between L and its perpendicular bisector that we calculated in part A. So if I go ahead and write this down, so I know that L has the equation of 3y minus 4x is equal to 21. And I know that the line, or the perpendicular bisector, has an equation of 4y plus 3x is equal to 53. Now, if we go ahead and solve these simultaneously, we'll get the result of y is equal to 11 and x is equal to 3. So we know that we have this new coordinate 3, 11 to work with, which is our point of intersection. So now, since we know that our shortest distance will be along the perpendicular bisector line, we can go ahead and calculate the distance between our point P and this new line here. And if you guys remember, the distance is just equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so if we go ahead and do this, just input our values, we will have 3 minus 15 squared plus 11 minus 2 squared. And this is just equal to the square root of 225, which is equal to 15. And that thus concludes this question.